keyframe every single one frame, you're not really giving the compression any chance to, you know, do its magic. If you keyframe every 500 frames, then, you know, you could be going way off target. So if you've got something that's super cutty, then yeah, you want to be keyframing a lot more often. If you've got something that's not very cutty at all, you can keyframe a lot less. The great thing about H264 is you can actually make it really lazy, and like an MP1, keyframing every 150 frames is like murder. Like, you just wouldn't do it. But H264 has become that clever that we found 150 frames, which you just think it wouldn't be able to survive with, pretty much is, as a general rule of thumb, pretty good. Haven't tested automatic of late. The early version of compression on automatic had a few bugs that kind of went wayward. I suspect they might have fixed that, which then in turn automatic will probably be your best setting. We've been very happy with our encoding quality and you know, don't fix what ain't broke kind of theory. If you as far as single pass and multi-pass is definitely going to be better. It basically looks at all the footage and works out all its algorithms and goes, okay, this is going to be the best way I can compress it, goes back and compresses it. Basically analyzes and then compresses. Also,
hit on time on that, do you think?
What?
You got any idea of the difference in time for the compression?
It's not 2 to 1, but it definitely slows down the process. But fortunately, computers are getting pretty fast that, you know, if in the case you're encoding hours and hours and hours of footage, then something you might want to experiment with. We encode commercials, so we obviously stick it on multi-pass as an absolute, because you definitely do get better results from a multi-pass encode. So that's something I'd definitely leave on.
Can I just a little question? Do you always keep the quality on medium? Do you look at the best or high?
The quality slider, when you're restricting kilobytes,
right,
doesn't actually make any difference.
Doesn't make any difference at all.
No.
Really? That's interesting.
To do with
just push up to high.
Yeah. No, unfortunately, it's a little bit confusing. If you've got an automatic data rate, then it's actually looking at the quality. Right, so if you just go automatic data rate, then pushing your quality up to best is going to make that kilobit a second a lot higher. Putting it down to least is going to make that kilobit a lot slower. Now, unless they've rapidly changed it and they're calling me a complete liar, that is, as of a year ago, the way it used to work. Everybody on the net had a lot of theories and said it definitely made a difference. And then I actually found a guy, I think out of California or something, that was on the team originally for writing compressor, and basically told everybody they're full of crap and this is the way it works. So I sort of trusted him and did some tests, and yeah, I couldn't notice any difference between least and best because we were actually restricting the kilobits a second to 1,000. Actually, I think I actually noticed a tiny bit of difference on least, but anything from sort of low to best didn't make any difference. I think least kind of went, oh, you're restricting to 1,000 kilobits a second, but I can kind of get you a bit of a smaller file size. And I think from memory, when we were making all these presets, I think it actually did sort of bring the kilobits a second down a little bit lower again.
I'm curious about optimised for download. What's that actually doing?
Back on the streaming, sorry?
Just on the menu, just had them under restricted, you know, when you're restricting.
Oh, right, yeah.
There's I mean, you see that in various other contexts as well.
Yep.
I often wonder what that's.
In the case, I think, so with compressor's basically calling up QuickTime to do all your fast data's download. So all it's doing is, if you're downloading off the net, it's basically looking, it checks the speed that it's downloading at, downloads enough, and then all of a sudden you'll see the QuickTime start playing. Right? So in the case of, if you are, you know, say, downloading from, if you've embedded it into a website, the H264, and you hit download, you'll see it will start loading, you'll see the little bar. Same as like if you go to the Apple site and you're watching a HD trailer, and you'll see that it will stay on the first frame, and once it gets to a certain bit, it goes, well, I'm downloading at this speed, and so at this speed, I should be able to get to the end by the time I start playing, because I've already got 5 seconds of buffer there. So that's what the download is. It's basically a little, doesn't make any difference to the quality of the file. It's just a little header in the QuickTime that's telling the QuickTime what to do.
Does that make the file size bigger?
No. pretty sure. It shouldn't, because it's just metadata, so you're talking about, you're probably talking about a little header file with 8 characters, which is going to change your QuickTime from 4.5 meg and 822 kilobytes to 828 kilobytes, so I very much doubt that it would be changing the file size. I just have never tested that, because we've always used fast start. And then in the case of most of our deliverables, you're usually emailing it, so they've got to download the email. It's not usually embedded into a website, or you're usually downloading it from FTP, or you've burnt it onto a disk, so it makes no difference whatsoever whether you had none or fast start, but you may as well leave fast start on. Then we get to resizing controls. Unless they've dramatically improved it, we found that this didn't really do a whole lot. We've left it off because it speeds the encode. And there's different ways of actually resizing stuff. But if you were going from something like a HD file and you're making a 640 size, H264, you're doing pretty major scaling algorithms, so I would definitely be turning this stuff on. But it does definitely slow down your encode. So once again, computers have got faster and faster and faster. We've left it off simply because we're going from 720 down to 640, and the scaling it does as rudimentarily quite fast scaling for 4.5 MPEG, you're not going to notice the difference on anyway, and you just get faster encoding. So if you can take the hit in encoding time, turn it on. You've got several adjustments there, so if you've got something in the sense of if you've got interlaced footage, there's no point in encoding interlaced footage to a computer file because all computer monitors are not interlaced, they're progressive frame. So you're going to have lots of weird little lines from your interlaced footage on the H264, so to speak. The only format that really supports interlacing is DVD. I mean, these formats support it, but you've got to have a device to physically play it back on. So in the case of something like an Apple TV that's going to play back out to your plasma, which doesn't really handle interlaced anyway, so that argument's probably a bad one. If you've got an old CRT, but more often than not, especially with most formats, and MPEG-1 doesn't support interlace whatsoever, you can send an interlace file to it, but you're going to see your little jagged edges of your fields. So what you want to do is get your footage to a progressive format, either by doing it before you encode or turning a deinterlacer on in the encode. That's quite important because otherwise your footage is going to look pretty average. But more and more people in this room are probably working with progressive frame formats. Is anyone working with interlace?
We make DVDs.
Sorry?
We make DVDs.
You make DVDs, so DVDs are like
we're always fighting with fields.
Yeah. So, in the case of DVDs, they're great because you put it in a DVD player and it's going to go onto a plasma, and the plasma's going to go, this is fields, I know how to deal with it. You stick it in a computer, the computer straight away deinterlaces the DVD, or you stick it in a DVD player and play it on a CRT, and it's going to play the fields no problems. So MPEG-2, not a problem with that. H264, 99.99% of people are going to be playing it back on a computer. Computers don't support fields.
So if say you've got a sequence in Final Cut,
Yep.
do you deinterlace it within Final Cut and then export it?
I wouldn't, I'd let this do it,
Okay.
because you'd want to duplicate the sequence. You've got the render time of deinterlacing it to export it.
Yeah.
You've got all of that. And what for when this program will do it. And at the end of the day, you're going down to a shittier little format, and the deinterlacing in it's, it's not the best, but unless you're using a high-end program or a field-to-frame converter, which I don't know of any good ones for Final Cut anyway. I'd never do my deinterlacing in Final Cut anyway, so, but I can't remember the last time I deinterlaced anyway, so it's not something we deal with. We do have a plugin on the DS that we use as a field-to-frame, which is probably the best job I've seen around. But it's slow, and it's probably only good for commercials, and you're talking, once again, it's no point putting it through that to then go and encode a H264 that you're really probably not going to notice the difference on by just flicking this deinterlace on.